Welcome back to our basic calculus class, and this time we're going to talk about one-sided limits. Our objectives are to evaluate one-sided limits and to describe the relationship among the limit of a function and the one-sided limits associated to it. In our definition of a limit, it is a requirement that f is defined on some open interval containing the number of a, not necessarily at a itself, for the limit of f as x approaches a to exist. Thus, if we are to evaluate limit of square root of x plus 1 as x approaches 0, for instance, the limit will not exist because there is no open interval containing 0, such that the function given by f of x equals square root of x plus 1 is defined. However, observe that as x takes the values that are close to but greater than 0, the values of f become closer and closer to 1. So, kung atong values is greater than 0, natay result in which our values of f become closer and closer to 1. Pero the values are lesser than 0, we don't have the values of f. Hence, we can say that the limit of f as x approaches 0 through the values greater than 0 is 1. And this is called a one-sided limit. So before, if we are going to get the limit, like the limit of theorems, we can say directly if there is no given limit does not exist. But here, we need to find where's the limit. Is it before the given value of a or after the given value of a? The lesser or the greater than. So that is one-sided limit. So first, we're going to talk about the right-hand limit. So these are the limits closer to the given value of f of x, which are greater than the given value of a. That is the right side, the positive side. So here is the definition. Let f be a function defined on some open interval a, d. Then the limit of the function of f as x approaches a from the right is L, which is written as limit of f of x as x approaches a from the right is L. So the positive sign, the superscript indicates from the right of a. If the values of f get closer and closer to 1 and only one number L as x approaches a through the values that are close to but greater than a. So the right hand limit are the values that are tako sa a. They're closer and closer but greater than a. And the other one, we have the left hand limit. So this is from the other side. So the less than the a. So let us define. Let f be a function defined on an open interval CA. Then the limit of a function f as x approaches a, maniha, the limit of the function f as x approaches a from the left is L. It is written as limit of f of x as x approaches a from the left is L. If the values of f get closer and closer to one and only number L, as x approaches a through values that are close to but less than a. So this is as x approaches a from the left. Those are values lesser than the value of a. So let's have some example. Let f of x is equal to 1 plus square root of 2 minus x. Notice that f is defined at every real number less than 2. So let's write the limit. Limit of 1 plus square root of 2 minus x as x approaches 2 from the left, or the value of the values less than 2 is equal to. Let us use the limit theorems. So first, ato lang i-separate limit of 1 as x approaches 2 from the left plus limit of square root of 2 minus x as x approaches 2 from the left side. So equals, we know the limit of 1 is, the limit of a constant is the constant itself, so 1. Then plus, so limit of 2 minus x as x approaches 2 from the left. Proceed, 1 plus square root of, so the limit of 2 is 2, right? And then the limit of x, this is the variable, is equivalent to the value of 2. So we get 2 equals 1 plus square root of 2 minus 2, that is 0. So the remaining now is 1. So that is the limit of 1 plus square root of 2 minus x as x approaches 2 from the left. Take note, if the right hand, ito na hinamduman, if the right hand and the left hand limits exist as x approaches a are both equal to L. So, pag nag-exist ang right hand and left hand limits tapos kapareha sila og number, then the two-sided limit, which is limit of f of x as x approaches a is equal to L, also exists and is equal to L. So, meaning pag ang limit sa right hand o left hand kapareha nga number, so ang limit sa general nga value ana is exist, which is equivalent to the given L of the two sides. Okay? On the other hand, the two-sided limit does not exist. So natay conditions kung kano sa ang two-sided limits does not exist. Una, at least one of the one-sided limit does not exist. Meaning, if the right hand exists and the other left hand does not exist, automatic, the two-sided limit does not exist. And also, in reverse, if the right hand does not exist, tapos ang left hand does exist, automatic, two-sided limit does not exist. Or, both of them exist. We have the limit for the right hand and limit for the left hand side, but they are not equal, meaning they are not the same. So in short, the limit of f of x as x approaches to a is equal to L. Meron tayong limit if and only if the right hand and the left hand have the same limit or equal number of L. Theorem 1.3.1. Limit of f of x as x approaches a is equal to L if and only if limit of f of x as x approaches a from the right side equals L, and limit of f of x as x approaches a from the left side equals L. So meaning ang limit sa right hand ug left hand the same sila og number. Then in general the limit of f of x as x approaches a is equal to L. So there is a limit. Example. Note that limit based from the example a while ago, note that the limit of 1 plus square root of 2 minus x as x approaches 2 from the right side, meaning greater than 2, does not exist. Nga naman, kay kung imong pulihan og 2 point something, like for example, this x greater than 2 from the right side, so 2.5. 2 minus 2.5, we got negative 0.5. So square root of negative 0.5 does not exist. Equivalent to I. Okay? So the limit as a whole from the right hand of this expression rather, does not exist. Okay? Since the function given by f of x equals 1 plus square root of 2 minus x is not defined at any real number greater than 2. Diba? A real number, if you still remember the real number system, yung imaginary, the other side, the complex, which is I, the value of, we know that the value of square root of negative 1 is equal to I. In short, not defined at any real number. In this expression, greater than 2, the positive, the right hand limit, we cannot give a certain number on that. This also means that the limit of 1 plus square root of 2 minus x as x approaches 2 in general does not exist. Bisan pa ang sa left side ganina na atay limit. Right? Kay in the rule, itong nabasahan nga pag any sa side does not exist tapos ang sa meron automatic does not exist in general. Okay? Examples. Consider the function f of x is equal to 2 if x is greater than 1. F of x equals 1 if x is equal to 1. And then f of x equals negative x if x is less than 1. Evaluate each given limit if it exists. So we have 3 givens. For letter A, limit of f of x as x approaches 1, the right side. Diba? Positive right side. Greater than 1. Closer and closer from the right side. We're going to consider the value x is greater than 1. So, from the given itself, we have here, if x is greater than 1, we're going to use what? F of x equals 2. Right? So, what will happen now? Limit of f of x as x approaches 1 from the right side equals limit of 2 as x approaches 1 from the right side. So limit of 2 is 2. So we have the limit which is 2. So nga nung naa may 2 diri a. So we know the value of f of x from the given. If x is greater than 1, here sa indicator nga nung greater than siya, this one, the plus sign, which is from the right side, meaning greater than 1, closer and closer from that side. So we got 2. So our limit for f of x here is 2. So the limit of 2 is 2. Next, we have letter B. So we have limit of f of x as x approaches 1 from the left side. So from the given function here, we have x is less than 1. So our f of x is equal to negative x. So we have limit of f of x as x approaches 1 from the left side is equal to limit of, substitute na to ang value ni f of x, we have negative x as x approaches 1 from the left. So applying the limit theorems that the limit of the variable is the value of a. So we got negative 1. So that is the limit of f of x, which is equal to negative x, because our x approaches 1 from the left side. So that is the negative sign, or the left hand side limit. So, kanya to gamiton. Next, limit of f of x as x approaches 1. So, unsay atong gamiton? From here, now we need to have the generalization based from the remarks and notes ganina. Nga this is the general one. This is the right-handed, and we have the left-handed, and this is the general. Kanos magka-exist ang limit sa general if ang right hand o left hand kapareha og L. Here we have 2. Here we have 1. Dili sila kapareha. So naputay daw ako condition kanos asya does not exist in general. Una, pag ang usa ka side does not exist, ikaduhan, meron silang limit. In this case, merong limits, pero they are not equal. Limit of f of x as x approaches 1 does not exist. Why? Because the limit of f of x as x approaches 1 from the right side is not equal to the limits of f of x as x approaches 1 from the left side. So that is the conclusion. That's why we have does not exist limit on this given example. So that's it for our one-sided limits lesson. So take note, we have the right side and the left side. So in general, we can say that there is a limit if and only if, ako lang balikon, number 1, if the two sides, the left and right, have the same limit or they arrive at one certain, usa lang ka number, kapareha sila o number, then makaingot nga, limit does exist. The limit does not exist kapag one side of the limit, either the right or the left, does not exist, tapos ang usa nag-exist, automatic does not exist, as according to the remarks. And then also, if both sides, there is a limit, but they don't have the same number or L, automatic does not exist. So that's it for our one-sided limits.